All right, cool. So we've started recording as well. As I was just saying, high performance computing is like the broad term for working with a compute cluster or doing remote processing. And we're going to focus on the ARC cluster at the University of Calgary, as that's like a U of C specific resource for us. But there's others out there around, in like the Compute Canada network and that kind of thing. So the very first thing I want to do is a little poll just to get a sense of how familiar we all are with the kind of language I'm going to be using, so that I can adjust appropriately to make sure that everyone's following. So let me launch this poll. Fourth question, who has a pet, is clearly the most important. I'll give it like a minute or two just as a general sense here before we get started, and then we'll quickly show the results and move on. I say that question 4 is most important, but it's fine if you have a pet or don't. I'm not biased one way or the other, although I do have a cat. All right, great. Quick responses. I'm just going to end here. I think I can share the group. All right, cool. So we've got lots of people who've done programming before, which is nice. That'll definitely help. Those skills will come in handy here. About half and half who's used Linux and who is not, so that's great. Actually, well, I have the percentages here. It's 70% have used Linux before, which is nice. I have assumed in this presentation that most of us are using, Mac computers as their kind of user-friendly Linux, essentially. It's different than Windows PCs, but Mac and Linux share the same kind of language overall. So if you've used Linux before, some of this will be familiar. If you haven't, that's okay. It's nice to know that some people haven't, because I'm going to be trying to, make the concepts and the commands that I'm talking about understandable to even people that haven't seen them before. 2 people have used a cluster like ARC before. Well done to you, and to the other 12 that answered no. Great. Again, my goal is to kind of let this be your first look into what that's like, and then you can decide whether that's something you should put some effort into learning and pursuing, or if it's not for you. And then we're pretty even on who has a pet or not. About 60% yes, 40% no. So that's great. Okay, so moving on. Like I mentioned here, my goal for today is to give you an overview of what a computing cluster is and when to use it. The kind of the bulk of the presentation, once we've kind of given that broad overview, is going to be, what are the steps to using a compute cluster, and I'm going to kind of walk you through it and show you the commands that I use and the text you should be familiar with to actually work with a compute cluster. And I realize that if you end up saying, okay, this isn't actually something that I'm going to use in my day-to-day, that actual walkthrough might not be for you. So, feel free to stay or leave. I won't take any offense if anyone dips out, because this isn't something we're actually going to use. Compute clusters have very strong strengths, but also drawbacks. So it's up to you whether you decide this is a useful tool, like anything else. Oh, I've also put in a reminder here to share some files with you. So let me just do that quickly once I can get my Zoom menu to pop up. I made a very rough, there we go. I made a very kind of quick and dirty cheat sheet for all the different commands that I think are important. I'm just going to post a link to a Google Drive that I have these files in. Feel free to go and download those too if you like. So one of them, like I said, is kind of like a cheat sheet of different commands that will be coming up throughout the presentation. And I really just wanted to have them all in one place that you wouldn't need to worry about taking notes, and you'd have it for reference later. The other one is a sample job script that is kind of the basis of how you interact with ARC. So that will kind of touch on, midway to the end of the presentation. But when I was starting out, I would have loved having a template just to kind of plug stuff into, so I didn't need to understand the language as well as I do now. So I thought I'd make one for new people as well. And as I mentioned, we are recording this session. I'm going to put it on my YouTube channel nearby my MRI tutorials. So it'll be up for whenever you need to actually refresh yourself on this material. And we'll have like kind of some timestamps for the different topics as well. So I'll try and make it as easy as possible to move through this material again. So with all that out of the way, let's actually get started. So what is a compute cluster? It's essentially, what people call a supercomputer. It's a cluster of computer resources arranged in a very fancy way that we don't need to go into right now. Other people have done a great job of that. But the general concept here is, if you're doing processing on a PC or a Mac, your average computer these days is going to have one processing unit, the CPU, maybe a graphics card, 8 gigabytes, 16 gigabytes of RAM, which is just your kind of working memory in your computer, and maybe a terabyte or 500 gigabytes or something of storage space. The ARC cluster has over 1,200 of these different nodes, and each of those nodes has between 8 to 80 processors instead of the one in your computer. They can range between 12 gigabytes and 3,000 gigabytes of RAM, of actual memory to use. And you're given, if you sign up for this server, 500 gigabytes of storage as well. So right out of the gate, the whole purpose of a compute cluster is to centralize a huge amount of resources for every researcher at the University of Calgary to use. This is an example of a NASA supercompute cluster, where they're doing stuff like managing the Perseverance rover and doing COVID research and all this cool stuff. I don't have any pictures of the ARC clusters, although I imagine they look similar to this. But that's kind of the general idea. They're very commonly used in research of all kinds. And the benefit here, aside from just having tons and tons of resources to use, is that you can now do processing in parallel. So, if I have a project where I'm processing 50 subjects and each person's processing takes roughly a day, that would take me like, 50 days, 2 months to process, just doing one after the other, linking them up. It's going to take a while because I have one computer. But the whole, benefit of ARC, I would argue, for graduate students and postdocs and researchers like us, is that you can do parallel processing, which means, in the ARC structure, you can submit 50 jobs to 50 different, compute nodes that are out there. And even if it takes 1 day per person because you request like the same amount of resources as you have on your regular computer, that just cut your processing down from 50 days to 1 day. Or you could request more resources and maybe the processing takes a few hours, and suddenly you've got your whole cohort of data processed in a couple hours. A huge savings of time, and that's really, why I would recommend this to any of you. There's, of course, some drawbacks. We'll get to those in a bit. In reality, you don't actually like go to that room with all the computers and like plug in your laptop to talk to the computers. You can access them via terminal. Like I have this picture over here. This is what you see when you log into ARC. You see a little splash of saying, hey, welcome to the ARC cluster, and then you can do what you want. So it's not quite as glamorous as going to a bunch of computers with a NASA sticker on them, but the payoff is worth it in terms of time, absolutely. And because this is a research cluster, plenty of the tools that you might want are already available, like MATLAB and maybe Python, and for me, stuff like MRTrix, that program's already on there, or ANTS if you're doing your imaging registration. If this is all Greek to you, it's fine. Just kind of letting you know that this system is set up to have a lot of useful programs on there for you, so you don't have to do everything from scratch. In terms of the structure of how to work with a computer cluster, what happens is from your personal computer, you will contact ARC. You will log into the server. You'll see that splash screen that I just had on the previous slide. And at that point, you're interacting with a thing called a login node. Let's see my cursor kind of circling that on the diagram here. This is a kind of a dedicated node, a dedicated computer, which you talk to request jobs from the actual set of really powerful processing units and nodes that are part of the Arc cluster. So I like to think of this as when you're talking to the login node, you're talking to a restaurant server, somebody who's taking your order and passing it back to the chefs, which are your actual nodes that are doing the computing. That's the compute nodes over here, which that's where there's 1,200 of them in the Arc system. And this is an important structure because it allows everybody who wants to talk to those compute nodes at Arc, they just go through that one login node, they submit their jobs, and then there's this scheduler that kind of arranges, when each person's job is going to get processed. This is important because you're never actually, well, sometimes you are. In general, when you log into Arc, you're talking to this login node, which is not where you do your processing. You actually have to use this whole job submission system to send kind of a recipe backstage to the compute nodes, to the chefs, and they'll complete your work and send it back to you. So that'll come up again, but this is the general structure. You kind of give your order to a server, which works both in the restaurant metaphor and in the compute metaphor, and then they send your order to the chefs or the compute nodes, and then your processing gets done behind the scenes. We're going to focus on just kind of your personal storage today at the Arc cluster, which is your home directory. There's actually a couple different sets of storage you can access, but generally we're just going to focus on your home directory, which is personalized to your account when you're working with Arc. So now that we've kind of talked about what the compute cluster is and how it works, when should you actually use it, or should you actually use it at all? So like I mentioned, working with a compute cluster like this has some strengths and some weaknesses. The strengths are quite clear once you kind of get the hang of it, once you learn the ropes. You can do multiple different processes at once using, because you have access to multiple computers, essentially multiple different nodes with their own resources. You don't have to buy 50 computers. You can just submit 50 jobs to Arc, and that saves you a lot of time and money. There is also the opportunity to use more powerful resources than the ones that you have in your own computer for tasks that take a long time. I've got some examples here that are relevant to me and probably nobody else, but just to kind of talk you through one, this Node processing, that's something that I focused on quite a bit in my PhD work. And when I started, you did the processing for Node on MATLAB, and the toolbox literally took a week for each person. And I had like 40 people to process. So I was like, okay, this is going to take me a year of time. And then if I mess something up, or if I find out somebody's data was corrupted, I need to re-download, that's another week of time to process each person. That is a nightmare. How do I make this feasible? And ultimately, by learning how to set that process up on Arc, which maybe took a day of time or so, some conversations with the support staff, I made a pipeline to do the processing on Arc, and took that week of processing where I had 4 cores on the one CPU and I think 16 gigabytes of RAM to process this stuff. Instead, I requested a 16 core processor with I think like 50-ish gigabytes of RAM. And anyway, the processing went down to 4 hours or so, which made it much more feasible to actually do the processing in parallel. And then if somebody needed to be reprocessed for some reason, I could just do it again in a couple hours instead of having to wait a week. Huge time saver. And the last strength here is that if you're doing this processing on Arc, you're not doing it on your own computer, so things aren't going to get laggy or slow down. If you are just kind of pushing it off to some outsourced resource that's going to do your work for you while you kind of read papers or do whatever else it is you're going to do with your time. There are some weaknesses though to Arc. First, it does take some time to kind of learn how to use the system. That is very natural. I'm trying to make things as easy as I can for you with that cheat sheet and with this kind of walkthrough presentation / video for you to look back at later. But the first few times you do it, it is going to feel like probably a different language. It's going to be a little bit confusing, and that's fine, because the way it works with computer science processes like this is once you kind of figure it out once and you write down the steps that you took that worked, you've figured it out for next time. So just kind of keep track of what you're doing, and you'll eventually get more familiar with it over time. Because you're working with this within this scheduler system, which we'll talk about in more detail later, it can be a little bit difficult to understand, what went wrong when something did go wrong. In which case, this email address for support from the high performance computing group, the HPC group, is your friend. They are quite prompt on their responses and quite helpful in terms of figuring out what went wrong or how to kind of adjust your requests or your processing to make things work. They can be a lot of help. And another kind of hurdle to get over here is, because you're using a compute cluster where you're kind of sending these orders off, they're being processed in the background, and then the results are getting sent back to you. It's not quite as responsive as if you were doing that processing on your computer, which has its own drawbacks, but we'll kind of walk through that as well. It takes a little bit of a different skill set to understand kind of when things work and when things don't, and kind of keeping track of what actually happened on the cluster. But again, once you're kind of familiar with it, once you've learned the ropes, it becomes quite doable. There's just kind of a learning curve to working with a resource like Arc. Is everything kind of making sense so far? Any questions? I am keeping an eye on the chat for the record, but again, you're welcome to just pop in whenever you like. I also want to note that I have tried my hardest to keep like pictures from the matrix off of every slide when I was making these, and I did such a great job, but then I realized that I made the password to this Zoom call the matrix, so I really shot myself in the foot before I started. So 2 different minds on that one of all the matrix jokes, but it really feels like you're in the system when you're working with Arc sometimes. Okay, so how do you actually use Arc? I haven't addressed this yet. What you need to do is email that support group and mention, who you are, what you're doing, and how you're planning on using Arc. And then they'll kind of, at least when I signed up a couple of years ago, they had a meeting in person. Maybe it's a meeting on Zoom. Maybe there's no meetings required anymore, to kind of talk you through, what's going to happen when you're using Arc, just to kind of verify that your, use is appropriate. But because of that, I am kind of focusing more on, talking you through the content today, which isn't my favorite presentation style, but I think it made more sense because I'd rather, anybody be able to attend instead of needing all of you to sign up and get accounts if you might not use them and all that stuff. So if you want to use Arc, you need to send an email and request access, and then you'll start the process of actually signing up. But for today, I'm just going to kind of walk you through stuff. The actual, interactive learning experience can happen later on, and I'm happy to help with that, but not so much today. I'll do my best not to be boring, though. I've got kind of a quick and dirty, set of steps that kind of summarize what happens when you are working with Arc, and we're going to kind of use this as a set of signposts for where we're going to go next in the presentation. There's not too many steps to actually working with Arc once you've kind of figured out what it is that you'd like to do. I'm going to be focusing on this example of using FreeSurfer software, as the people that that I advertise this to are mostly neuroimagers. So I assume most of us will have this as kind of like a semi-familiar example. But if you're not familiar with FreeSurfer, that's fine too. It's just a simple example. It's something that takes maybe 8 hours or so to process on a personal computer. So doing that on Arc saves a lot of time. And the whole idea is you put in MRI image of the brain, and it spits out tons of information, including these handy 3-dimensional surfaces of the brain, and measures like how thick the brain is and how voluminous different structures are, how much volume they have. So that's going to be kind of my one example that I'm focusing on for today, but you can apply the same concepts to any processing that you want to do on Arc that might take a little bit of time and is doable on a Mac or Linux computer. And while I'm kind of on that, I'll mention you can do this processing with a Windows computer. You're gonna need to download a different program that you can use to connect to the server, because Windows doesn't come with the correct tool like Mac and Linux does. That's fine. You can definitely do this all. I've done it on a Windows computer. Things might look a little bit different, but the commands are all going to be the same once you kind of get familiar with that other program that you would use. Okay, so before we actually jump into, how to work with Arc on a daily or weekly basis, we need to talk about kind of how you arrange things correctly to run a job on Arc. So I put this first, and then we'll do like the actual steps of processing afterwards, but they are very intermingled. The first thing you need to do, when you want to use Arc is actually get the data that you want to process onto the server, because if you have a file on your computer that you want to run through FreeServer or whatever else, it may look something like this, where it's in a folder. You know how you want to process it. You point the program that you're using to that file, and you're good to go. But if you do the same thing on Arc, the compute cluster doesn't have access to your actual local storage, so you need to move your data onto that 500 gigabytes of storage that's allocated to you on that home drive that's accessible by all of the different compute nodes that Arc has to actually run processing. So if the file on my computer looks like this, it's just called t1.nifty. When I actually move it to Arc in the terminal here, this is the exact same file that I've moved onto Arc. It's in a place that I've specified. It looks a little bit different because I'm using this ls command to list all the files in a certain directory in the terminal, but that's the same file that I've moved onto Arc. And the way that I do that is with this command down here in blue, rsync. This is a command that you would type into your terminal, and then you give it a bunch of instructions, and this rsync program, this command, will do what you want it to do. So there's other ones out there like SCP that you can also use to copy files to a remote server like Arc, but rsync is my favorite because it has this update function. So let me just walk through the command first, actually. So we have rsync, which is the command you want to use. Then you have these flags that are behind a hyphen here. It's -var. These are different flags that you use to tell the rsync program how you want to do the command. So we'll come back to those afterwards. Next, I have this file that I want to transfer. It's this file that I've got highlighted here. It's on my desktop. t1.nifty, and then after that we have the location that I want the file to go, and that's my account on Arc is called blgiray, and then it's at arc.ucalgary.ca, and then I've specified a directory that I want to move to. So this is kind of similar to the folder that it's in on the desktop, where it's my home directory and then the desktop folder. Here, after I've pointed it to my account on Arc, it's my home folder and then this subfolder that I've made called example. Now these flags, just to kind of give you an idea of what they mean, the V letter here tells rsync that I would like it to be verbose when it's doing the processing, so it'll actually put out little messages telling me what it's doing and how it's doing it, it helps to kind of understand when things are working and when things aren't. The U for update is by far the most helpful for me function of rsync, which is that rsync looks at the file that you have and the destination, and if there's any data that's already there, it will kind of it will not replace that data. So if you have a transfer that's a few hundred gigabytes in size or something, and the transfer fails halfway, then you've got 50% of the data is on Arc and 50% isn't. If you use another command, you might use to start from scratch and move that whole thing again. With this update flag, rsync will just look at what data is missing and move that on. So it kind of allows you to do, it allows you to recover from failed transfers or partial copies of data, that kind of thing. Very, very handy. And this R flag lastly stands for recursive, which lets you kind of specify one folder, and then this rsync program will move that folder and everything within it, which is handy because otherwise, if I had 10 imaging files in this desktop folder, then I would need to run a different rsync command for all of them 10 times. Not that convenient. But if I use this recursive flag, then I can just say, rsync move this folder, and it'll say, okay, I'm moving this folder and everything in it, those 10 files are also going to go on there. Then it's just one command. So that's what recursive means. And that recursive function is in a lot of different commands, so that might come up again. All right. So once you've got your data on Arc, another thing that you might need to do is actually get the right programs onto the server, or onto or just like load up those programs to actually have them available to use on Arc. Like I mentioned, a lot of them are already available, but not all. I'm just gonna, oh wait, we're good. I had a notification that my keyboard disconnected. I assumed it had died, but it's back, so great. Don't need to stop to fix that. So in terms of this FreeSurfer example, it's pretty easy to use FreeSurfer on Arc. All you have to do is, download FreeSurfer and then move it onto Arc using something like rsync. And this is my copy of FreeSurfer that I've got in a little programs folder in my home directory. And that's all that I need to use FreeSurfer on Arc, because it doesn't come pre-installed. Other programs do come pre-installed though. That's what this module avail bullet point means. So let me just kind of show you that. I think I'm going to need to share my screen instead of just PowerPoint to bring up my demo terminal. Let me kind of, your view may change as I adjust. I need my Zoom commands to pop up. Great. New share desktop. All right. I don't think I left anything incriminating on my desktop, but we'll see. All right, cool. So we got our PowerPoint here. I need the cameras to be elsewhere. I'm going to load up a terminal. Great. Terminal. Okay, so this is essentially what you would be using if you have a Mac to connect to Arc. So I'm just going to quickly connect myself to the server here, the login node. I've made the text of terminal a little bit bigger for readability. Hopefully that doesn't bite me in the butt eventually, but here we are. I have connected to Arc using this command. SSH stands for secure shell. If you don't remember that, it's fine. You don't need to. You get this splash screen, and then here we are. I can now give any commands that I want to Arc. So the one that I want to use is module avail, which short for available. This is a command where I'm asking Arc to show me all the programs that it has installed for me to use. So if I type this, there's going to be a big long list that pops up. You can see up here, it starts with this AFNI program and goes on from there. We've got ANTS as well, which I mentioned before, helpful for neuroimaging. This is going to take a while to scroll through. Might be helpful though, so I'll go for it. FSL is on there, again, for neuroimaging. Eventually we'll get to MATLAB, which is another thing you use. There it is. A bunch of different versions are available. MRTrix is right there if you're doing tractography like I do. Not biased at all. And there's all kinds of other stuff. Python, we see R and RStudio. There's a whole bunch of stuff. And if you know more of these programs that I'm not mentioning, you probably are way ahead of this tutorial anyway. So if I want to use, let's say, MATLAB, because most people use MATLAB at some point in their lives, in this field anyway, I'm going to want to use MATLAB R2020A for this example. If I want to do this on Arc, all I would need to do is type module load MATLAB, and I could specify R2020A if I wanted to, because there's other versions as well, and just press enter. And then I've basically told Arc that I'm going to use this program, and it's prepared to use that program now. It's loaded the resources, it's added to the path. The path will come up again later. But if you have a program on here that you want to use and you don't need to add it yourself, you can just load it using the module command. So that can be quite handy. Let's go back to our PowerPoint once I find the right slide. Okay, it looks like the path variable is the very next thing that I'm talking about. So this is a concept that might take a bit of time to wrap your head around if you're not familiar with it. The path variable, it's very important though when you're interacting with the computer on this more basic level. In broad sense, the path variable is a list of locations that the computer knows to look when you give it a command. That's all it is. So, for example, when I type in rsync, the computer needs to know, where that program that I want to use rsync is. By default, that location, which is probably like a bin folder somewhere, is already on the path, which is great, because then when I type rsync, the computer will kind of look through its list of locations for where that program might be. If it finds it, it will run the command. But if you give a computer a program, or sorry, if you give a computer a command that it doesn't recognize and it can't find the name of that command to run in any of its listed locations on the path, it'll give you an error saying, hey, we can't find that command you want to run. So if you're doing something like I am and using this FreeSurfer program, that's something that I personally added that I want to use, I'll need to add that location to the path variable, and I'll show you what that looks like in a second, in order for the computer to know, hey, when I'm talking about FreeSurfer, look in this folder, this FreeSurfer folder, because that's where all the commands that I'm going to be running actually are. So hopefully, in a conceptual way, that makes sense. I'll show you what it looks like. It's a whole bunch of gobbledygook. You don't need to worry about the nitty gritty of it at all, really. But the path variable, it's relevant when you're working with a terminal like this. It's relevant in MATLAB and other places as well. Got a question in the chat from Eli. Ooh, good question. How does loading Python work with virtual environments in ARC? So I would like to unfull screen my slides here. Excellent. Simplest answer is I don't actually know. I haven't used virtual environments on ARC yet, but I see that it has multiple versions of Anaconda installed for Python. So I guess, yeah, I haven't actually worked with virtual environments in ARC, so I'd be speculating as to how they work. But most likely, once you module load one of these Anaconda versions, all those Conda commands will be available to you, so you can just kind of work with your virtual environments as you normally would. But I couldn't tell you where exactly your directories would be for those virtual environments. That might be a question for the support staff, because they might have a default structure that you would use, or maybe it's the case that you can just like make your own directory and then create virtual environments in there. Not 100% sure, but because Anaconda is installed on ARC like this, that should be quite doable, I imagine. Okay, so here we are on ARC, and I'm going to use this echo command to show you what the path looks like. In terminal, this $ represents a variable, so I'm looking at the path variable right now, and when I press enter, this long string of stuff comes out. And this is our path variable. It's just a list of locations where the computer might find a program. So you see that I loaded this MATLAB version, and now the location of that software on ARC has been added to my path. So before, if I typed MATLAB, ARC would have been like, what are you talking about? I don't have a MATLAB program anywhere. I don't know how to run that command because it's not on the path. But if I load that program in, now this path variable has the location of the MATLAB software. And if I type MATLAB now, I won't get an error anymore because the computer knows where to look. So I feel like at this point I might be beating a dead horse, but that is essentially the whole purpose of the path variable. It's just a list of locations for the computer to look. And if I want to use FreeSurfer or something, I'm going to need to add that to the path, which will come up in the example later on.
Question, Bryce, if I may ask a question.
Absolutely.
Yeah, how do we know what toolboxes are available within MATLAB? So if we've loaded SPM12, Cat12, Con, is there a way to check that?
There probably is. I imagine there's a, I feel like I might have even used this command in the past. I would be doing some Googling right now to confirm. I think there's a command in MATLAB you can use that will just list all of the toolboxes that it has available or it has loaded. But I don't know that off the top of my head.
Well, that's okay. I can Google it. Thanks.
Yeah, my answer would be either there's a command for that, which would be very helpful for sure, or if that command it doesn't exist and I'm just making stuff up, you could email the support staff and they would be able to tell you what each version of MATLAB has available, because scrolling up here, there's 4 different versions of MATLAB available, so maybe there's different toolboxes for each. Yeah,
Okay,
hopefully that
great.
helps them. All right, great. So back to these slides. Hopefully this is tracking for everyone so far. Next up, we have our data on Arc. We have our programs that we want to use either added to Arc or available through the module command. Next is actually creating the recipe that you're going to request Arc to run for you. Mixing metaphors here, but you have to create this thing called a job script. That's just a list of commands that you want a compute node to run in the background. So I'm going to break down the general structure, and in that Google Drive that I shared a link to previously, which please let me know if you can't access that or can't download those files. I just set it up this morning. I have an example job script in there for you, which I can there's a slide to walk through, how I've set that up at the very end. But it should hopefully help save you some time when you're making these job scripts of your own. I think I've covered the general stuff. Just jumping into actually the structure of this thing. This is just a text file. It can have whatever name that you want it to have. And you're going to submit it to this job scheduler using the sbatch command, which will come up later. But it needs to have a certain structure in order for Arc and the different compute nodes to understand it. So there's 4 sections that matter the most. The first is this interpreter line. This essentially tells it tells whoever is reading this job script what kind of interpreter to use. You will never need to change this command, so far as I'm aware, to work with Arc. It needs to be the first line in your job script, but you don't need to worry about changing it. It just needs to be there in order for Arc to be aware that the rest of the script is a job script, and here's how you read it with this bash interpreter. Don't worry about that too much, it just needs to be there. Next up, I have these comments. Anything that starts with a hashtag or a pound symbol doesn't get interpreted. It's not read by Arc. It's just there, as notes for me and you to understand what's going on. So that's just my personal notes. Next up are these sbatch commands, and this is actually the section where you specify how many resources you need for a job. So you can see here time. I've requested 48 hours, 2 days of processing to do this, recon command, which we'll get to in a bit. This hashtag sbatch little string there, that little chunk. That's how you start a line where you're requesting or where you're specifying kind of how the job is going to run. There are plenty of different flags you can put afterwards, whether it's time or how much memory you want to request. Here I've requested 8,000 megabytes or 8 gigabytes of memory to run as well, to run the processing that we're going to do. And then after that, we have this variable setup, this place where you're going to be, adding stuff to the path if you need to, in order for Arc to find the programs you want to use. Or here you might, put module load MATLAB or a module load Anaconda and then activate a virtual environment. That would all go kind of after the job specifications, but before the actual commands, because that's where you're, setting up the environment that you want to use for your processing. So this is the structure of what you need to do to start FreeSurfer on Arc. You have to tell Arc where FreeSurfer is at this FreeSurfer home variable. Then you need to set a subjects directory, and then finally you run this script called setupFreeSurfer.shell, and that's how I or anyone sets up FreeSurfer to run on Arc. But if you're doing something different, this section would change. And then finally, you have your job commands. I like to have this echo, which prints a message. It says, hey, we're starting this command at and here's this date variable, which will print out the time exactly down to the second where your processing started. And then once your commands are done, then you print a message saying, here's when it's finished, so you know how long your processing actually took. And in the middle, I have this command to run the recon all processing in FreeSurfer, which is basically the main FreeSurfer processing pipeline. So that's the general structure of a job script. You have this interpreter, never changes. You tell Arc how many resources you need and how long you want to request processing time for. Then you set up your environment and you run your commands. And when you submit that to a compute node, that's all you need to do. You can just walk away for the rest of the day. And if all goes well, then your processing will be done by a compute node if everything's set up right. I've got a little note here that it can be kind of a hassle to create these scripts for 50 people, like I was doing for my Node processing. There are ways to speed that up, including writing a script that writes these scripts for you. It's a little bit next level, or you can use something like Excel to kind of quickly glue pieces of information together. We're just going to kind of glide past that for now, so that we can focus on the Arc side of things. But there are ways to kind of set this up in a way that you don't need to manually write this all out or anything like that. Copy and pasting is an option, and Excel is a good way to do it too. If you're familiar with that. If not, just ask me that question. We can quickly give a demo how that works. All right, so I want to quickly touch on these different ways that you can request request resources on Arc using these sbatch commands. There are tons and tons of flags available that you can use. Here are some of the most useful ones. Generally, for all of us just getting started on Arc, these first three should be included in each of your scripts. They don't really need to change. You're just requesting, one compute node and running one task at a time, and then requesting one CPU per task. Unless you're doing something fancy where you're actually using like threading and parallel processing in a more literal sense to run commands on multiple different CPUs that are all talking to each other. Again, that's more advanced in this tutorial. If you're not doing that, you can only use one CPU per task. That's how serial processing works. So pretend that you're using just one computer for each task. And these are kind of the three, lines here: nodes, end tasks, and CPU per task that specifically request that many resources. Essentially, we'll get into this in the scheduling side of things, but if you don't specify them, then it might take a little bit longer to schedule your job because Arc doesn't exactly know how much you need or how many resources you need. It relies on its default assumptions. So it helps to have these first three lines in there, and you can just put them in the script and never change them until you're ready to ascend to new levels of computational intensity. These next two are also really, really important in terms of just how much you are requesting in terms of resources. First, how long of a time do you need to do your processing? This is 24 hours, and that'll come up once we talk about scheduling. And also how much memory you need is another important one to make sure you specify, because if you don't have enough memory for your command to run, things might go really slow. And if you request a lot of memory, you might be kind of using those resources that they're just sitting idle while others could be using them. So it helps just to kind of specify roughly how much memory you need. But of course, always overestimate, because you want to accidentally request too many resources instead of requesting too few, and that takes too long, and you reach that 24-hour window, and then your job gets canceled because you hit the time limit and it's not done. So these two, time and memory, are important to adjust depending on the job that you're doing. These other two that I've got here, I'll just briefly touch on for those that might be familiar with Slurm already. This partition one lets you choose which partition to use, because each different partition on Arc has different amounts of resources available. So sometimes it might help to request a node that has enough resources for your job already, or might be kind of used less than other more popular nodes by other users. And this last one I just learned about this week. You can specify, sorry, this partition equals should actually say outputs equals, and then, or maybe it's just output singular. I'll have to look that up. Sorry. You can specify a custom output file name, and that makes it a lot easier to track what you were actually doing when you're reading the log files, which is very handy. I wish I knew about this years ago. But this one is saying, okay, when I have an output file, name it slurm, hashtag a custom name, hashtag the job ID out. Sorry, those are definitely percentage signs, not hashtags. I'm still waking up here. But it's fine. If you don't know what I'm talking about, that is okay. It's a way to specify a custom name for your output files, which can actually be very helpful. Okay, so once we actually have our data on the server and we have our programs on the server and we've written our job script, so we have successfully written that recipe so that Arc is going to know what to do for processing, then we can actually try it out. Until, again, this week, because I found a handy resource on Arc processing to learn about this presentation. Until this week, I had followed the cross your fingers method of submitting a job and hoping it works. And if it doesn't work, then reading the log file and figuring out where the error was and troubleshooting it and then submitting a new job. And let me tell you, that is a hassle because actually figuring out what the errors were in your processing, it's time consuming. Computers are not the most clear communicators. They sometimes just they give you errors that don't make sense, or they just don't understand what it was that you were trying to say because of some syntax error. And anyway, it takes a lot of time to troubleshoot all the different errors that you could run into when you're setting up a job like this. Hopefully I've kind of skipped some of those errors for you by providing that example job script template. But there's another method that you should be aware of that's really, really helpful to set up your job for the first time, and that's salloc, which is, slurm allocate. It doesn't really matter. The command is salloc, and here's a example command where I am requesting a node on this lattice partition. Don't worry about that too much. This is shorthand for those three commands that are three requests that should never change. Nodes 1, number of tasks 1, and compute or CPUs requested 1. So all of this can stay the same or similar. Then I'm requesting 1 gigabyte, 1,000 megabytes of memory here, and 30 minutes of time. And if I actually type that command in like I have done, oh, it's actually not on the screenshot, but just above the screenshot, I wrote that command in to Arc and pressed enter, and it allocated me a compute node to test on. So I haven't really explicitly harped on this yet, but when you're talking to the login node, it's tempting just to run processing there, but you really never should. That's in the cheat sheet as well. It's just when you're working with Arc, don't actually run commands on the login node where you're talking and working with your data and setting up those job scripts, all that kind of stuff. Don't run processing there, because other users also use that exact same node to manage their jobs. And if you run processing that kind of hangs or it uses up the resources on the whole node, then other people can't actually use the Arc service, and the scheduler might not work as efficiently. So it's not a place that's designed for processing to happen. That's what the compute nodes are for. So if you want processing to happen, you submit a job, it goes to a compute node, the processing gets done. That's what the login server is for. But if you want to do some manual testing, like I have been talking about on this slide, what you can do is request access to a compute node. That's what this salloc command is doing. And if you just kind of set, type this command in, request some resources, and send that command to the login node, then it will, it might take 30 seconds, it might take a minute, it might take 5 seconds. But eventually you'll get connected to a compute node, which uses the same syntax, it's just more powerful. And there you can test your processing out. You can basically manually run the commands in your job script to set up your environment and run your processing. And see if things work or see if there are errors at all, and then adjust your commands and your script as necessary to avoid those errors in the future. So this is very helpful because it skips that whole need to submit a job, wait until it gets scheduled and finishes or exits with errors, and then read the commands. Everything is just, it's happening in the terminal. It's like you're working at your personal computer, except you have this powerful compute node to test on. And once you've kind of verified that your commands are all, correct syntax, the file names are accurate and all that stuff, your programs are set up correctly, then you know that any JavaScript you send to the server is going to work. So you can exit your testing period and actually start submitting jobs. So salloc, very helpful, would recommend when you're testing your jobs out. And this is kind of the last step for you to actually set up a job on Arc. After that, you're just going through that roadmap of basic processing that I had set up before this section. And that, I guess, is what we're talking about next, is actually running a job on Arc. So once you have your job script set up correctly, this is the one example that I had before for some free surfer processing. This script is called example.shell. And all I need to do to tell Arc to run this processing is type this command right here, sbatch example.shell. That's just the file name. So the sbatch is basically submitting a command for processing, and then you tell Arc where the job script is. Because I'm already in the directory of the shell script, I don't need to actually write out the whole path to the file name with the home folder and then /example/example.shell script. But that depends on kind of your working directory, which is kind of some that's some base level how to work with terminal knowledge that if that's new to you, that's totally fine. We can work through that as well. Just shoot me a question if that doesn't make sense, if you run into an issue there. And when you're actually submitting a job, here is an example. I am submitting a command that I had ready for free surfer processing. You get this message where it says submit a batch job and then a number. This is your job ID. This is the kind of like the tracking number that you can use to ask Arc, what's going on with this job. One command that you can use to do that is sq. The syntax is actually wrong. Let's look down here instead in the command sq-u, which stands for user, and then my username. This command sq-u, my account name, will show you all of the jobs that you have running, like all the jobs that are happening on Arc that are associated with your account name. So here I have this batch job 9296209, that's the job ID. And when I say, hey Arc, what processing is running? It'll point out or put out this little table. Here's the job ID. This is the partition that it's been assigned to. That's the name of the script that's running. The account, its status. R stands for running. There's also P for pending, and I think there's Q for queue as well. Scratch that. It's PD for pending. But anyway, the status, you can look up the codes if you want. There's this Arc wiki that the University of Calgary has made, which is actually quite nice. They did not have that when I started. It has this time column, which shows you how long it's been running for, which is very handy, how many nodes you've got, and this actual list of the nodes that you're using. Don't really worry about that. The ones that that help me anyway are the job ID, its status, and its time, and also the name to keep track of which job is which. Next, I have canceled the job with scancel and then the job ID, and you can see when I use that sq query again to figure out, hey, what jobs are running? That job has disappeared because I have canceled it. So this sq command helps you to know what processing is actually running, whether it's whether something you've submitted is running, whether it's waiting for a scheduled time, or whether it's done, as in it's not there anymore. All right, any questions so far? Things kind of making sense? We're probably I don't know, 2/3 of the way through the presentation for the record. Cool. So let's actually walk through how to run a job on Arc. We've spent all that time walking through kind of how to set yourself up for success on the Arc cluster, how to actually get your job to work. So now we're just going to kind of walk through a very related process of how do you run an individual job on Arc. And this comes back to that structure of the Arc cluster that I had up here before. First, you need to, oh, hey, thanks for coming, Ephraim. The video is available, but yeah, nice to see you. So first, you need to connect yourself to the University of Calgary network. If you're, working on the U of C campus, this is not an issue for you. I, being based out of the Children's Hospital, have to use this VPN called 40 client. It's, it's distributed through the University of Calgary IT software database. There are guides for how to install it, and it is very handy. Would recommend for multiple reasons. The first of which is you can actually, connect to the Arc server, but also, pro tip, if you have a computer and you connect to the University of Calgary network using this 40 client VPN, you can also just you can search for papers and go to the website where you can download the PDF, and then you are logged into the University of Calgary network, which means you can access those papers instead of seeing that paywall or subscribe before you can access this PDF barrier. So by connecting through 40 client, you can just download papers more easily than having to log into the University of Calgary library or something. Very handy. So let me show you what that looks like by going out of my PowerPoint. Here is 40 client. Once I've got it installed on my Mac, it's just this little icon up here. And then once I click it, I can connect to some VPNs that I have established. And again, there are guides for how to do this if you need to on the University of Calgary, IT software distribution webpage. So I'm going to connect to just the general University of Calgary network. My account name, this is my IT account, which you might need to set up, but likely already have. It asks for my password, which I'm going to try and remember off the top of my head. And if I type that correctly, then this page will just disappear and it'll say, hey, you're connected to the network. Cool. Turns out that message doesn't exist, but it's fine. There's that icon up here is changed to a lock. That means that I'm connected to that VPN, or that network rather. And that means I can connect to Arc. If I wasn't connected to, to the VPN, sorry, my terminal's going very slow. Not sure exactly why. Anyway, if I wasn't connected to the University of Calgary network, then I wouldn't actually be able to connect to Arc. There would just be a long waiting period, and then when I'm using that SSH command to connect to Arc, and then it would say, hey, connection timed out. You could not connect. Oh, well, I'm just going to terminate that for now. Okay, so back to the slideshow here. Once you connect to University of Calgary network with 40 client, you can transfer your data either to Arc or from Arc using that rsync command that I talked about before. You need to actually be able to connect to Arc to do this, but you need to run the command from your personal computer. You can't really do it once you're connected to the Arc server, because then you're talking to a login node, and that login node doesn't know where your personal files are. So this is something that you would do before you connect to Arc, but after you connected to the University of Calgary network. Hopefully that makes sense. So say, for example, I wanted to move that t1.nifty file in my example folder onto Arc. Here's the command I would use. The syntax again is rsync, and then some flags that are optional that I had in the previous command. And then you need to put in your data and then the address that you want to send it to, the actual destination point. And that would be your account name at arc.ucalgary.ca, and a colon lets you kind of specify a folder within your home directory to send it to. So this colon tilde is just kind of a placeholder saying, just send it to the home directory, that's fine. That's what this tilde actually represents, is the home directory. That's in your cheat sheet as well. So if I was doing that from my personal computer, I could say, rsync this t1.nifty file, and then send it to my account in the example folder of my Arc home directory. If you're worried about having to type all these file names in, I have another handy trick for you. For that, I need to jump out of the PowerPoint and launch another terminal window. Once it actually does so. Not 100% sure why my computer is struggling this morning. That's fine. If you need to specify a file and you don't want to type out the whole name and you have a Mac or likely on Linux as well. I actually haven't used Linux in so long I've forgotten if this function exists. But say I have this, mos_view.py file, or actually I'll go find the example file. I just need to actually open the folder. Very, very handy. I want to move this file onto Arc. So let's say I type rsync, and then I can just drag or click this file and drag it into terminal. Let's see, actually, okay, there we go. So you see I've got it by my cursor. If I just let go, then the entire path to the file is written out. So it saves a lot of typing. Would recommend doing that to save yourself a headache, especially if that is a complicated path, like that is multiple folders deep. It's just a whole thing. But if you can just drag and drop and save yourself a lot of time. And say I wanted to move everything in this folder, instead of just that T1 file, I could just say rsync this directory, or I could drag and drop this whole directory, and it would get added to the path there, which is great. Saves you a lot of typing, definitely. So you can use rsync to actually transfer the data that you need to Arc. If it's already on there, then great, you can skip step 2. Then, after you've actually transferred your data to Arc, you can actually log on to the system and begin to submit your jobs. So that is with the SSH command, and then you have to type in your account name at arc.ucalgary.ca. It'll ask you for your password for your IT account at the University of Calgary, and once you put that in, you'll be connected to Arc. You'll see that splash screen, and you'll be good to go. And then you just schedule a job. You have your job script ready because you've done that whole, setting up your job and creating the job script thing, that process before. You just type sbatch some job.shell, or whatever the name of your file is. It doesn't actually need to be a shell script, but I find that just using that shell script extension helps me to remember that's what that file actually is. If you have a whole bunch of files to submit, like say you have 50 job scripts for 50 different people, there's a way to loop through this using some syntax in your actual terminal. I'm going to put it in the chat, and because I didn't put it on the screen, but it can be very helpful. Let me just write it out here. It might look like nonsense to you, but it works. So just in chat, I have a message that shows kind of how you would submit multiple job scripts if you have them all in the same folder. So say you're in that directory with all of your job scripts, and you type for F in asterisk, semicolon, do sbatch $f, semicolon, done. What that means is for every file in this directory, for F is just a variable name, and the star represents everything in this folder. So for each file in this directory, and then the semicolon says, here's the next command, get ready. The next command is do sbatch, and then the variable name, the name of that F file, which is, again, just kind of depends on where you are in the script. But with the syntax, you can just say for every file in a directory, sbatch that file. And then the done just means once you've done that, you're done. Or once you've done that sbatch, you're done with this line, move on to the next one. So it's just a quick script, a quick for loop, if you're familiar with those, to submit a whole bunch of sbatch, or a whole bunch of job scripts. Can be helpful, instead of having to type sbatch 1, sbatch 2, sbatch 3 so many times. Okay, so now we are actually at job scheduling, and this is the other purpose of this presentation. Essentially, number 1 was how do you set up a job script. Number 2 was how do you schedule a job. Those are the things that are kind of unique to Arc, that are different from processing on a regular computer. So how do you actually schedule a job? Well, you use those job scripts, and you're interacting with this scheduling manager called Slurm, or a job manager that actually takes everyone's requests, and it figures out how to arrange them all onto different nodes with different resources and time limits to create the schedule of processing for all of those 1,200 compute nodes at the University of Calgary to execute in a timely and efficient manner. It is a reference to Futurama. If you don't know it, that's fine. It turns out programmers just, they name things because they think they're funny mostly. So somebody was a fan of Futurama, they created this thing and they called it Slurm. It's, it's just, computer science is weird sometimes. But the whole purpose of this Slurm job manager is you have those commands like sbatch, like sq, that and scancel as well, I've talked about, that's where you're interacting with the Slurm job manager. And its purpose is to, again, take all of those requests and schedule them accordingly. And it does this in a fairly logical way. The ARC cluster is fairly busy. There is plenty of room on the cluster for processing to occur, but depending on the amount of resources you request, Slurm might have an easier or a harder time scheduling your job. Like, say, for example, I have done this in the past, you request 7 days of processing time because you're processing Node data and you really want that 1 week of time to make sure that your job doesn't get canceled halfway and then you just start it again. You schedule 7 days of time, which is 168 hours. I know because I've made that request many times. Sometimes it will take Slurm a long time, like multiple days, to schedule your job because it's looking for a 7-day window that it can set aside on a compute node that nobody else can use that time anymore because it needs to find that 7-day window that's specifically for Bryce's Node processing. That could be much more difficult to fit in than if you, say, requested a node with higher resources, like instead of 10 gigabytes of RAM, 100 gigabytes of RAM, so your processing will happen more quickly in theory. And instead of requesting a week of time, you request 24 hours. Then the Slurm job manager only needs to find a 24-hour window on a compute node where there's an open space to slot in your job script. That's a lot easier to find time for because Slurm has to manage everyone's job requests at once. So the takeaway on this slide and when you're scheduling jobs is the fewer resources and time you request, the easier it is for your jobs to get scheduled. I didn't know that for a long time, and it would have saved me a headache had I known. So the more accurate you can be about your job requests, the better essentially for you, because your jobs will be scheduled more easily. But again, you always want to kind of overestimate the amount of resources that you need, at least a little bit. And part of the testing period of setting up those jobs might be kind of figuring out how many resources you actually need for the processing to occur. So there's a process here. I think rule of thumb and the way I've set up that example job script is just pretend that you're going to use a computer like your own with one processor with like 16 gigabytes of RAM or something. And how long would it take for your processor or your computer to do this processing? Maybe it takes a day, then you request 24 or 36 hours or something. Just kind of use your own computer as a benchmark, unless you're kind of amping things up and requesting more resources, and then you might need less time. There's kind of a process for you to get familiar with there. But rule of thumb, request less so that your jobs happen more quickly. Okay, and with that, your job is scheduled. And now we're in the kind of the loop of, checking did things work? And if they worked, great, then you can move on with your life. And if they didn't work, what's the error? How do I fix that? And then submit a new job. So there's kind of a little whirligig whirlpool loop here that I've got between steps 6 and 7. Which I'm actually not going to focus on too much today because it's very like case by case basis kind of thing. Like not everyone's going to be doing recon processing or Node processing or the examples I've used so far. Everyone's going to be doing something different. So actually troubleshooting that, I actually am happy to help with. If you want to just send me an email, we can work through it together, or ask other people who are knowledgeable in your field. But it takes a little bit of time, and once you've sorted out the right syntax, the right file structure, that kind of thing, it'll work for all of your subjects or all your processing. So it's kind of like a set up your pipeline once and you're good to go from there. But in general, some tools that are available for you as you're kind of monitoring your job process. First, you have the SQ command. Ignore this first part. This is actually a different command that I brain farted on last night. But when you use the SQ command with the -u flag in your username, you get a list of all of the jobs that you're currently running. If you want to see how much of how many resources, how much RAM is being used, that kind of thing for a specific job, instead of using SQ job ID, you actually use saccount job ID, which let me actually just exit PowerPoint because I've done that enough today, and change this so we actually know what we're talking about. Also make this more capitalized while we're at it. All right, cool. So saccount job ID will give you a little table that's different from the SQ one. It'll say, okay, you've asked about this job that's running right now. Here's the amount of resources it's using on this node, blah blah blah. It's a bit of a table. There's a whole bunch of info in there, and we don't need to focus on it today because it's a little bit more advanced, but it is available for you to be aware of. And another thing you can do is look at the output files from your processing. So if things worked, then the files that get produced will be there. You can check those outputs. If they look good, then great, you were successful. If things had errors, then you can check the kind of the logging file for what happened during the processing. And this is what I did for much of my life before I knew about that salloc command. The type of file that gets saved for a Slurm job request is called slurm dash and then your job ID dot out. And just going back to that SBatch slide I had before, you can change this output file name if you want to make it easier to understand. Yeah, I cannot tell you the amount of times that I have just had a list of job names and I thought, oh, I can remember all of those job names, and then I couldn't, and I forgot which was which, and just it's easy to get confused with just slurm and then a big long number dot out. So custom job names can help. But anyway, this file in it is saved all of the messages that are output during your processing. So for recon processing, it is a long list of commands. You have to spend 30 seconds scrolling down to get to the bottom of it, which looks like this. For a successful one, recon processing finished without error at this time. And then I have my command saying, hey, we finished the processing on October 9th in 2020. Nailed it. If there are errors, they will be in here. Sometime it'll say oh, file not found, or in layman's terms, we couldn't find this program. Computers are never that clear. They have more archaic messages, but you can usually Google the error message to at least get a start or an inkling of what went wrong. I've got some kind of pointers on the most common errors for me anyway later on. But yeah, the Slurm files are very, very useful to figure out what actually happened during processing. It takes, if you're doing that testing on salloc on one of the compute nodes and you see all those messages put out in the terminal when you're doing your processing, all of that is stored when you're doing actual processing on a compute node in the Slurm file. So very helpful kind of log of what happened during each job's processing. Okay. Now we're pretty much at the end of the presentation here, but when you're actually troubleshooting errors, there are a couple things that I would recommend. Again, like I just talked about, check your Slurm output file. Were there any errors in there? If so, they'll probably be at the bottom in this kind of traceback format. Generally, I would read from the bottom up because at some point right near the bottom, there will be the most clear message of what actually happened in your error. If you're not familiar with that, just try reading from the bottom up and see if you catch anything that is human readable instead of just a list of who knows what, depending on the program you're using. And again, Google can often be effective in figuring out what went wrong because thankfully in neuroimaging and likely in your field, if you're somewhere else, you're not the first person to do this kind of processing, and somebody else will have had the same problem. So thank goodness for Google there. That saved me many times. It's also an option to just email the support staff at hpc.ucalgary.ca, and they can kind of help you to troubleshoot. Sometimes they do speak a different language, but honestly, they are quite good and quite responsive. So if you explain, oh, I don't understand what you're saying, or you can have a conversation and figure it out together. They are quite good, and they've saved me many times as well. But by far, the most common error that I have had is just having, file names be wrong, or locations of files be wrong, or setting up the path so that Arc knows where it should expect to find those programs. That actually, like the path variable being wrong. So just honestly, the first thing that I do when I'm troubleshooting is make sure that every file name that I've put in is absolutely correct. Like I will, say, since it's on the screen, I have this home slash blgray slash data, and then this folder name, and I expect some file in there to be processed. I will just kind of like read out the file name and follow the path actually like physically in the terminal, to make sure that that path is actually correct and points to the file that I want it to, because many times I will accidentally change a folder name, or use an old script where the file structure that I was using was different, and just catching those errors, it probably accounts for like 2/3 of my problems. So just be really double check or triple check that your files are right, and that your setup is right for your programs. All that stuff causes a lot of errors, just because if one thing is wrong, then that will kind of stop the whole program. The computer is not good at improvising and saying, oh, you probably meant this thing. This, you used a capital letter where it should have been a lowercase, or that kind of thing. Those things can catch you. Also worth noting here, generally a lot of programs that we'll be using don't like file names with spaces in them, or special characters other than like dashes and underscores. So I've gotten in the habit of just naming my files with underscores instead of spaces, and no like percent signs, dollar signs, whatever else, because that throws a lot of errors in all kinds of programs. So generally keep your file names simple and readable for your sanity and for Arc to understand you. And the last thing that I have to mention here in the troubleshooting section is, if you're working in your home directory, like we've been talking about today, you have 500 gigabytes of space. And if you run out of space, if you're over that limit when you're doing processing, your job will just get canceled with an error. And sometimes it has taken me a while to figure out it's a space issue. So I can't recall the exact error that you're given when you don't have enough space, but I've remembered it being confusing in the past. So one thing that's good to keep track of is how much space are you actually using. I typically use this du command in the terminal. Du stands for disk usage, in case that helps you remember it. These flags, S and H, I forget what S stands for, but it's helpful. H stands for human readable, so it will actually, output something like this, which will show you, how large each of the folders in your directory is. So this one's 4 megabytes, this one's 84 gigabytes, and then, you can do some simple math to see, does this add up to 500 gigabytes? If so, you gotta delete some stuff, you gotta transfer some stuff off of Arc and delete it to clear up the space. Just make sure you have enough space to do your processing. If you need more than 500 gigabytes, you can access other storage resources in the work and scratch directories, but I'm not really talking about those today, because this is more of a getting started guide than a I am an advanced Arc processor guide. And that's basically the whole process. It's just going through this set of steps once you've set up your job, and doing that processing. So you kind of got the idea. This can take a little bit of time to work through, but it can result in huge time savings once you kind of put in that initial effort to set up your pipeline. Might not be for everybody, but that's how this tool works, and now you can hopefully kind of decide whether the tool might be useful for you in your more computationally intensive tasks. Like, not everything is worth putting on Arc if it just takes 5 minutes to do on your computer, but if something takes, rule of thumb for me, honestly, is if I'm running something overnight, it's probably faster for me to just run it on Arc. And even then, it might not be worth the effort of setting up the pipeline, but sometimes it really is. So it's a tool that you can choose how to use how you like. And my last 2 slides. One is just, here's this cheat sheet that I've put together for you. It is not my finest graphic design work, I will be honest. I added some color with a little ball in the top there. I don't know why. I was doing this at 9 p.m. last night. Don't question my scheduling skills. But it's got all the commands that I talked about today here, and hopefully it's a helpful like 1-page reference for you to kind of summarize things. Yeah, when I was learning the syntax and how all this stuff actually worked, because I wasn't that familiar with Terminal before I started my graduate degrees, having something like this would have helped me a lot, just to kind of have all those commands in one place. So hopefully it helps you as well. I'm happy to reorganize or add anything. I was hoping for some feedback on kind of like what's missing from here, so I can create a version 2 today in case anyone thinks something is kind of missing off of the sheet. I'm happy to change it or add stuff, but the general stuff is there. I realize now I forgot to talk about actually like editing text in the terminal, which I can, I guess, talk about during the question period, just to kind of show you what that's like. It's quite simple, but easier than doing it on your computer and having to download and upload your job scripts all the time. So we'll talk about that in a second. And last here is the job script template that I have made that might help some of you. Everything is kind of set up here just to kind of give you some structure. And the areas in red would be areas that you should change depending on the work that you're doing. So again, you should never need to change the interpreter, and all of us really only need to use one node and task and CPU unless you're doing actual parallel computing, in which case I can link you to another video that's a really great overview of how to do that. But for your jobs, you will want to change how long, how much time you're requesting, and how much memory you need, because that will affect, again, how easy it is for Slurm to schedule your job. Once you set your time and memory, then you have this section where you can add any variables or load any programs that you want to use. For me, it was kind of, setting up those FreeSurfer variables and then running that setup FreeSurfer script. For you, it might be module load MATLAB, or, module load Python, Anaconda, and then Conda activate this environment. All that stuff can go in this variables section. It's basically just anything that you need to run the commands that you want to run, which is the next section below. I do like to have these echo starting and done job at these date commands in there, just because then in your Slurm file you have an exact amount of time when it started and when it ended. Can be quite helpful. They're not mandatory though, you can cut them out. And then I would just put any commands you want to run in the actual script in this red section between those echo commands. So you will need to kind of change this file for each job and give it a different name, and then SBatch submit that job to Arc, but this is at least a helpful starting point. And with that, we are at the one matrix reference that I allowed myself. Does anyone have any questions about the tutorial today, about using Arc, anything like that? I'm happy to chat. And if we have some time, if there aren't too many questions, actually, while questions are brewing, again, feel free to jump in if you have one by voice or by chat. That's great. While questions are brewing, though, I will show you how to edit files in terminal, text files. Okay, let me just get out of this PowerPoint with Keanu Reeves' giant face now. That's fine, you can stay on screen for a little while. Okay, so I want to connect to Arc here. Keep things consistent. So I'm going to use this list command, ls, to look at all the files I've got in my home directory. I have this example folder that I've got for today, so I'm going to change directories into it. And then my working directory is this example folder that I just showed you. And in here I have this shell script, example.sh, that I add in some of my slides today. So the command to actually look at this file and see what's in it, which I use all the time, is vi, and then just the name of the file you want to look at. So if it's a text file, it'll be easy to understand what you're actually looking at. If you press enter here, the terminal now moves to this other window, and this is all of the text that's in this job script, which I had on a slide over here. It's the exact same thing, I think. But say for example, I uploaded the wrong Nifty, and instead I wanted to process another file called example_2 or something. I might be tempted to write a new job script and upload it to Arc and use that Arc sync command, all that stuff, to get stuff onto the server. But instead, I can just use this text editor to quickly, I've loaded the text file with that VI command, and now I can move around it with a cursor. I was just about to point to my screen. You can see this gray box moving around, that's my cursor. All I want to do is change this file name, so I'm just going to go to the right spot. I'm going to press I, which changes me to insert mode, which is, it shows that you're in this mode down here. That means I can now add new text to this file. I'm going to add an underscore, add a 2. And now my script is ready to process that new nifty file because I had the wrong one in here before. So now I want to save this script because I've made the change that I want. If I, type anything else, it's still going to be in there because I'm in insert mode. So I need to press escape to exit insert mode. That's where the insert little icon or indicator at the bottom goes away. And then to actually close a file, it's a little bit weird. You hold shift and press the colon key, and then you type an X. You can see at the bottom we have :X here, and that stands for close the file and save it. And if I press enter, then we exit the text editor, and now if I load it again, my change is still in there. So using this viewer tool, it's called Vim, is very helpful just to kind of quickly view your scripts if you need to, without having to interact with your local computer with different rsync commands. It saves you some time. If you just want to load something and need to quit without saving your changes or something, you just use :Q, and it'll quit the viewer. So that's how you can look at your job scripts on Arc, is just with the VI and then your job script name, which can save you a lot of time. Have any questions come up while I was going over that at all?
Hi, Bryce. I have a question about the University of Calgary VPN.
Sure.
So I haven't yet set that up. How do we do that?
Yeah, thanks. Let me show you. So I'm pulling in a Chrome tab here, or Chrome window. If you just Google University of Calgary software distribution, you will see this website, IT software distribution. There might be other ways to get to it, but I've always just Googled it. Right. If you go in here and you log in using your My U Calgary account, that information, or actually I think it's, well, let's see if this works. Yeah, okay, so it is just your My U Calgary account. We'll see if this loads for us. In here, there will be a web page with a bunch of different software you can download, like I think SPSS is on here and MATLAB and stuff. 40 client, there we go, is one of the options. It's right down here at the bottom. Okay. So under tools and utilities, 40 client, you can select it. And then you have the request a license function like you would for accessing any software through this web page. And in there, there's a guide for how to install it and how to set up these VPNs, the General U Calgary, and I think the admin as well, although I only use the general one.
Thank you.
Yeah, you're welcome. Anybody else? All right, I will.
Oh, sorry.
Yeah. No, go ahead, Madison.
I've been trying to formulate how to ask the question. I think it's maybe ultimately a little bit more a question of, exactly how does the parallel processing work? So if Arc, in my job script, if I had, a loop, I read through a directory of 10 subjects and put it into my recon all line, does Arc still know to do that in parallel? Is it not actually doing each of your subjects in parallel? It's more one subject's processing, different aspects are done in parallel.
Are you, so in this example, are you, I guess, okay, so there's, the difference comes in depending on whether you have created one job script that's reading in 10 different subjects and then running recon all on all of them, in which case it will do them in serial, run them in order like you would on your own computer, or what I would recommend instead is having, if you have 10 subjects, having 10 different job scripts, one for each subject, and then using that message that I put into chat, just saying, for F in, or for each file in this folder, sbatch that file, and then you're done. In that way, essentially, if you submit 10 different job scripts, then Arc will run those 10 different subjects in parallel. But if you submit one job script that says, process these 10 people in order, then you'll be running, you'll still have Arc doing that processing for you, but it'll be doing it in order, one at a time instead. And I'd say that the real benefit of Arc is running multiple separate jobs at the same time.
Okay, I think, yeah, that's helpful. So you use the for loop with the sbatch command to loop through job scripts rather than looping through your subjects, sort of.
Yeah,
okay.
Exactly. Yeah.
Cool.
So if I just jump into, in my terminal, the recon folder where I have all my scripts and I list all the files in here, right now I have, like 6 different subjects that are left over from Catherine's lab, and some other ones that I run myself. And if I wanted to process all of these shell scripts, one per person, instead of just having one job script for all of these files, I would use that command here. So for F in each file name that ends in .shell, then just do this command, which is sbatch it, and then you're done. So, and then if I do this, which I guess I can, there's no harm in it, it will just quickly loop through these jobs and submit each one of those shell scripts and give me a job ID for all of them. And then if I, type SQ with my username, then I have a list of all these files, which apparently are all running. Nailed it. No scheduling issues today. But yeah, that's how I would do my processing on Arc.
Awesome, thanks.
I wonder if I can cancel them all. Is this the thing that works? No. Oh wait, it did. CG stands for cancel, so nailed it. I learned something.
Hi, Bryce. It's really helpful talk. So I also have a really question about the GUI thing, the graphic user interface, because I think I also tried a little bit of supercomputer before, and I found myself trouble to for example, for MATLAB, there are a lot of like a toolbox. I'm more familiar with the graphic user interface rather than the. How did you do this kind of thing, like explore DTI? To set up a problem or batch in supercomputer.
Yes, I have always had. I wonder if I am remembering this. Okay, great. This might be a useful example. But so when working with MATLAB, I've always had to kind of find a way to set up the script or set up the processing such that you never load the GUI window, and you just so I found the most effective way to be finding the script that I want to use, and then creating a version of that script, saving it and modifying it so that it will work on Arc just by running the processing kind of in a more hands-off way. So I have mostly run the Node processing toolbox on Arc because it saves a lot of time. I haven't actually done any Explore DTI processing on Arc just because I never needed the time savings. Everything was pretty doable on my own computer, but honestly, looking back at it, if I was doing it again, it might be faster for that, EPI distortion or semi-automated chartography. All that stuff could be faster on Arc. The hassle though there is then I would kind of find that semi-automated chartography script and maybe modify it so it works when you give it a subject name or a file location or something. And then let's see if I can find a Node script here to show you what I've done in the past. Okay, let's see if I haven't looked at these in like a year, but they exist, so maybe they'll be informative. So this is some Node processing that a job script I had run. Oh boy, this is a mess. But for Node processing, here is essentially the command that I used to run it on Arc. It's not horrible. It looks terrible, but that's fine. So running MATLAB, what I did first is I loaded the version of MATLAB that I wanted to use, and then the command actually that's relevant is MATLAB with no display and no desktop and no splash, which means no graphic user interface is going to show up and confuse Arc. I don't actually know how that would work on Arc, but I remember seeing a recommendation just to put in those flags so that MATLAB just loads and operates without any visual components. And this R flag is going to say run this command. And so I told MATLAB to run this script that was just my Node processing script that I would use in a GUI, but now it takes these different arguments, these different variables, they're just long file names. First, I tell the script, this is the subject tag that I'm using. Here is the location of its diffusion weighted image, and then its bval file, its bvec file, and its fa mask. So what I did, to answer your question, is just quickly modified a script that I knew worked on my own computer to accept some variables that I could change on Arc to actually run the job by essentially pointing the script to the files in their correct locations, rather than having to say, manually type them out or select them from a folder dialog, that kind of thing. So yeah, that may have been a little long-winded, but hopefully it helps a little bit.
Yeah, it's really helpful. Thank you very much. Actually, it's my first time to saw how to run a MATLAB code like program, like just in batch.
Yeah, it's essentially the same. Yeah. I've never had to do that aside from Arc, but yeah. Oh yeah, my pleasure. All right, I will stop recording there. I'm happy to hang around for questions. Thanks for bearing with me today. Hopefully you all learned something and are either motivated to use Arc, or now you know how it works and decided it's not for you. Either way, I hope this was useful.
Thank you so much, Bryce. This was great.
Thanks, Bryce.